Hey guys, and welcome back to a new video. Today you are going to have your very first encounter with a date in Compose Multiplatform.
Don't give me hope.
Because you will learn how you can build this little world clock application, which will teach you the ins and outs of the Kotlinx DateTime library. Because usually if we are on Android, for example, then the typical way to deal with dates in the app and time zones is the local DateTime API we know from Java. But since it's from Java, we can't use that in Kotlin multiplatform projects. So in this video, I will show you how we can use the Kotlin equivalent of that API. And after building this little app where we just have major cities from around the world with their corresponding local times and the local dates, you should be settled and you should be ready to work with this Kotlinx DateTime library in any Compose Multiplatform project. So let's dive right into it. In here, I'm in a blank Compose Multiplatform project. In case you don't know how to create that, you need to go to kmp.jetbrains.com as usual, enter your project details, tick Android, iOS, and desktop. Those are the platforms that this video will target. Download this, open an Android Studio, and then it will look exactly like this. We can close the README file. We can also minimize our little device here, open up our project hierarchy, switch to the project view so we get to see all of our folders. And the first thing we need to do is we need to add the Kotlinx DateTime library to our project. And that works with the version catalog. So in Gradle libs versions.toml, here we want to add that library. First of all, we need a version for that, so DateTime, and that is 0.6.0 as of now. And we need the dependency string, which is this one here. So Kotlinx DateTime, you can also just copy paste this from a GitHub repository down below, or you just quickly tap this off. So it's a DateTime library from JetBrains, which is pretty good. So we get official support. We can sync this and then open up our Compose app module. And inside the build.gradle KTS, we can then reference this library here in our common main dependencies block. So we just can access this from across the project. And you can see it already suggests adding exactly that. The autocompletion gets smarter and smarter. So I want to type implementation libs Kotlinx DateTime and then synchronize our project. So we really have this library included in the project. And then we can open our source folder, go inside of common main, because that's in the end what we want to do. We want to share this DateTime logic between all of our targeted platforms. Open Kotlin, open our application composable entry point, and in here we can then get rid of everything except for the material theme. All right, what do we need here? We first of all need some form of a representation of a city. So if we take a look in our app again, then a city corresponds of its name and it corresponds of the time. So we can just declare something like a data class that makes a city. We give it a name so we can display that name in our list of cities, and we want to give it a time zone because obviously each city has its own time zone, and that is a time zone here from the Kotlinx DateTime library. And then we can take this data class and just create a bunch of these inside a list here in our composable. So we just have a list of val cities. We put this inside of a remember block and we just say list of, and we declare a city here. We don't want to assign the current system default, of course, for the time zone as is suggested here, but we rather want to define the real time zones of these cities. And for example, starting off with Berlin, we want to say, okay, that's actually Berlin, and we can then specify the time zone like this. You can see for some reason there are lots of indentations, but we can say time zone.off, and then we pass a specific zone ID. These zone IDs are universal, so usually they start with the continent the city is on, slash, and then just the city name. So it's very easy for you to actually type these different zone IDs, even if you don't know them by memory. And now we can just duplicate this, let's say 5 more times. So we have 6 cities in total. We can do this for London. That's also in Europe, but we replace Berlin with London. We then have this for New York, which is America / new _ York. This is how these IDs work with spaces. We do have, let's say, Los Angeles, I can't type Los Angeles, like that. It's also in America, and we say Los _ Angeles. Let's say we have Tokyo, which is in Asia / Tokyo. And lastly, let's have Sydney, Australia, Sydney. like this. So now we have a bunch of cities with the corresponding time zones, and we want to display each city's corresponding time now in our list and also update that once a second. So what we need is we need a list that actually also contains the actual time of that specific city given its time zone. That is what I would like to make a state here. So var city times, for example, make that by remember, so we just have a mutable state of here, just a normal compose state, and we say we have a list of, I will actually make this a list of peers, where we map each city to its corresponding local date time. And that is already the first very important concept of this DateTime API. If you know the Java DateTime API, this is exactly the same, but in the end, we sometimes either have a reference to a local time, so just a time representation based on the local time zone. For example, if a specific app reminds you of something every single day at the same time, then you don't care about the date. You just want to know, okay, which time should I actually remind you of something? In that case, you would make this a local time reference. If you just care about the date, then you say you have a local date. And if you care about both, so the actual date and the time, then we say local date time, which will then contain the information about both the current date and the specific time. We can then hit Alt-Enter to import this. For some reason, it doesn't like this. Did I import the wrong thing? Alt-Enter. No, I'm actually just missing an angle bracket here, and then we can hit Alt-Enter again, and the import works just fine. And what we then want to do is we want to have a launch effect block. So just a block of code that triggers once when the composable actually enters the screen. And in here, we now want to go through our list of cities. And for every single city, we want to take its time zone and calculate the local time so we can update this in our city times list. And this is something you want to do each second. So we also get these live updates that you've seen. So let's just have a while true loop where we delay this by 1 second. So every single second we loop over what we do here again. And then we can say we have our city times and we say, okay, that's actually equal to our cities, so our cities list. And we map each city to this corresponding pair, so to the city on the one hand, and the time of that corresponding city. And I don't think we can do what this suggests here. So we can say local date time dot now, because that doesn't exist. That was a concept from the Java DateTime API, but the Kotlin one works a little bit differently. Instead, what we need is we first of all need to get a so-called instant of now, so of the current time, which is equal to clock.system.now. An instant is pretty much just a timestamp, and it's always in UTC format. So UTC is the universal time something, which is pretty much the global reference time. I think it's actually London time, but there is a time zone which is always the standard for specific timestamps that are not formatted for a specific time zone. So whenever you talk to some kind of API or so, or you need to store time instances or timestamps in your local DB, then you typically do this in this UTC time zone. And then just in the last step before you display this time, you convert this UTC timestamp to the local time zone so you can also show that to the user. And with this UTC timestamp, which is a so-called instant, this concept also existed for the Java DateTime API, we can now say we take this current time and we convert this to, you can see you can convert this to epoch milliseconds, so to a milliseconds timestamp, or we can convert this to a local date time object. And that now takes the time zone, because a local date time object, obviously, as the name says, refers to a local time, so to the specific time of a specific time zone. And since this instant does not contain any references to a specific time zone, since it's always in UTC, we need to declare which time we want to have this UTC timestamp now in. And that's exactly just it. So our city.timezone. And then we could just go ahead, declare something like a lazy column. So we just have a list of all of our cities here. We make sure that the lazy column fills our whole screen's size. And in here, we will then have a block of items. I want to take this overload that takes in a list and obviously just displays our city times, which is a pair we can then destructure here. So we get the city and the corresponding date time. And then in here, we can now construct a composable that really displays a single city. If we take a look in here in our reference app, then this row that we'll put in here will consist of a big bold text for the city name, and then it will consist of a column here for both the time and the date, and we will use the space between horizontal alignment to push both these elements to the very edges of this row. All right, let's do that. We have a row where we say, okay, we definitely want this row to fill the whole screen's width. We could give it some padding here. In addition, 16.dp. We set the horizontal arrangement to arrangement.space between, and we center everything vertically, like this. Vertical alignment is alignment center vertically. Alt enter to import this alignment class. And in here, we can then specify on the one hand our text that displays the city's name. So text is equal to city.name. We can give this a font size of something like 30 sp, alt enter to import that, give the font weight of bold, and then down here we will have a column that will just keep the current time or the time of that specific city and the date. So here for this column we will have a modifier. No, we actually don't need a modifier, I think. We just want a horizontal alignment of alignment.end. So this will achieve that we push this smaller date text also to the end here of this column. And in here we will then just have two texts, one for the current time of that city and one for the date. And now we come to the next very important concept you need all the time when working with date and times in Kotlin or in general in software development, and that is formatting them. So right now, this date time instance, this local date time instance we have here for each city is quite an abstract data structure if it comes to displaying that. It's a data structure that makes it very easy for us to deal with these dates and to do date math. So if we want to maybe add 3 weeks to a specific date, then this API really allows us to do that easily. But depending on what kind of time or date we display, we want to show that in different ways typically. In order to do that, we use a so-called date time formatter. So if we want to format a date time instance, then we can say we have the datetime instance here, and we call that format, which then takes in this datetime format instance of type local datetime. And there are some standard formats, I think, local datetime dot, or is it datetime format? I think I forgot. There's at least some default formattings here, which are very unlikely you will use these for displaying these in your UI. These are typically used to just have an ISO format, so a unified format for a datetime string you can then send to your API or so. But here we want really our custom format where, take a look at our UI again, we want to have 2 digits for the hours, then a colon, 2 digits for the minutes, and also fill up the zeros if it's just a single digit. So if we just have 6 or 7 minutes, then I want to append or prepend a 0 here, and same for the seconds. And for the date, we then have a different formatting. And the way this works here is a bit different compared to the Java datetime API, where we just specify a pattern. So we just specified something like, okay, we have our hours here, we have our minutes, we have our seconds, and then the datetime API automatically figures out what to insert where. You can just take a look in the docs what corresponds to which value here. But in Kotlin, that does not work yet. There is a function, but it's discouraged to use that, at least if we believe the official documentation. So what we instead want to do is we want to say local datetime.format, which gives us this lambda block. And here we could specify a pattern. We type pattern, you can see by Unicode pattern, but this is not as flexible as the one from the Java datetime API, and it's also discouraged to use that, I've read somewhere. What we can instead do is, we can now define with a typical Kotlin builder-like fashion, we first of all want to have our hour, and you can see we can pass a padding, which is by default padding 0. So padding.none would be, we really just insert the hour without leading zeros here that I've just showed you. We can use padding space to fill up with spaces instead of zeros, or we can say padding 0, which is the default, to fill up with zeros. That is what we want, of course. We can then have a character, which is a colon. We then want to show the minute, also with our typical padding, have our character again, and finally have the second. And you could just go on like this. You could have the milliseconds, I think. No, this dot second fraction here. So with that, you could calculate the milliseconds, of course. So you get a bunch of information here you might want to use to display the time in the format you want. We can then take this and also give it a font size of 30 sp. I want to give this a font weight of light And then we can just take this text, copy paste it. So we also do the same for our date. For this date, I just want the font size to be 16 SP. And we of course need to change the formatting. Since we are dealing with a datetime object here, this also contains the date information. So in this case, we want to have these characters not be colons, but rather slashes or whatever you want to use as a separator for your dates. And here, depending on where you live, you might use a different format, but you might want to have the day of month as a first number. And then you might want to have the month number. And finally, the year. And we also want to put or set the text align to end here. So we really make this text stick to the end of our container. This should be it for now. I will also show you in a moment how we can do date math. That is something I haven't showed you till now. But let's first of all launch this on our device, and hopefully we should be able to see exactly the same type of app here. All right, it's launching, and that is looking pretty good. I'm in Germany, so you can see my time is actually accurate. And yes, that is looking pretty accurate as well. London is 1 hour behind Berlin. You can also see that certain cities are already 1 day past me, so they have a different date than I have currently, but that is looking pretty nice. Let's take a look at how we can do date math. That is something we don't really need for our use case here, but that is something you still need quite frequently in apps. And doing date math with Kotlinx DateTime also works a bit differently compared to the Java DateTime API. In that Java DateTime API, you could just say something like plus days, and you add maybe 30 days to that specific DateTime object. You could do plus minutes, add a certain amount of minutes. For some reason, these functions do not exist. Maybe they will be added in future, so you can check this depending on when you watch this video. But for now, the only way that works for us to do date math is to take this datetime instance, convert it to an instant, so to a timestamp representation in UTC, and then with that instant we can do date math and then convert it back to a datetime object. So what we could do is we could say .toInstant, we pass in the UTC offset .0, so to really have that timestamp representation in UTC time zone. And then we have this plus function and minus function where we can either subtract or add another instant, another timestamp. We can specify a duration. So for example, if we want to always add, let's say 20 hours, then we can say 20.hours, Alt-Enter to import these hours. And then we take each date and just add 20 hours on top of that. If we then say, okay, we convert this back to our local datetime object, where we pass in the city time zone, and we relaunch the app, then we should be able to see that each of these times now has 20 hours difference. No, actually, because we shouldn't convert this to a UTC instant, but rather to an instant that takes in the time zone of the city as well, of course. Because otherwise, we do get a 2-hour difference here. In my case, at least. Yes, now it's correct. So you can see previously it was 5 p.m. here in Berlin, but since we now added 20 hours, we instead have a time of 1 p.m. That is looking pretty good. So depending on what you need to do, you just need to do the conversion back and forth, but then you can also do date math just fine here. Of course, this will now also work on different devices. So if let's just launch this on desktop. You can believe me that this also works on iOS, but if we launch this here on desktop, open the main KT file, run this, we get the typical error I got in this whole playlist, but we can then open the terminal and launch it from there. /gradlew run. If we take a look, I minimize this here, and there we go. Here is our desktop program with all of our different time zones, and they're also correctly displaying each of these times. Very cool. I hope you enjoyed this. For more advanced Android and Kotlin premium courses, you will find a link down below. Check these out. And other than that, thanks so much for watching this video. I will see you back in the next one. Have an amazing rest of your week. Bye-bye.